Hey. Welcome, everybody. And already I see we have regulars on the show. It's just so
It chimed
great.
in before the music was even over. It's pretty awesome.
Right? And, so we have our favorite guest and troll, Richard Boyd.
Just kidding. Troll. I love it.
Richard's probably my favorite person right now. And then we have Worry21. Welcome back to the show. Great to have you here. Okay, so this is Containers from the Couch. Welcome, everybody. So thank you for joining us. If you were here yesterday, we have, and if you weren't here yesterday, we have had a special guest, Peter Dalbhanjan below. He is a specialist solutions architect who's been talking through Kubeflow, Kubernetes flow, kubectl flow on, I'm just kidding, Kubeflow on EKS. And we had a really cool demo yesterday of just getting it set up, seeing all the components, all the commands it takes to get going. And today we're going to set up some Jupyter notebooks, which, is it fair to say that's like the IDE for the machine learning folks? Yeah, right. It's like their IDE. So that'll be really good. So looking forward to getting that going. But before we start, I guess I want to say, is there anything anyone wants to say or add before we dive into things?
Richard apparently has lots to say. He wants to call it Kubeflow. So that's awesome.
I've never heard that before. But
and instead of Jupyter notebooks, he thinks it should be Jupyter's notebook. So
okay, all very good points. And we're gonna go ahead and take those back and put them up for discussion.
Right. And Worry has lost track of the mustache count, so I did update it. It's been 10 whole days, Worry. So yeah, still looking good. Have you had to trim it along the way?
A little bit, and I have to tell you, I feel like I'm constantly trying to sell a MyPillow with this mustache. But as I go, I'm just next. I'll have the blue shirt and the necklace. Anyways, I'm kidding, but great. I think I have a MyPillow. So
we should have a video on how you keep it trimmed. Just I need some instruction there, so I want to find out the secret.
Absolutely, and I'll tell you this: the beauty of 720p and low def is that you don't get to see all the imperfections in my mustache. So this is why 720p. So if this was a live conference or we were talking live, it'd be horrible. Like this is just the beauty of all production. I don't even know what I'm saying.
Yeah. So we are live. You know that, right?
You're not talking to yourself anymore.
This is all recorded. None of us are real. This is our newest service at AWS called Containers from the Couch AI.
Three bots get together and chat.
Anyways, I digress. I say we get into it. So, Peter, why don't you kind of talk us through what we're going to do today, and then when you're ready, we'll get into it. We'll start sharing the screen.
Yeah, let's do that. So, yesterday we spoke about what Kubeflow is, what is machine learning, how you can use Kubeflow. Essentially, Kubeflow gives you all the tools that are required if you're a machine learning developer. So you can go and quickly write your algorithms using Jupyter Notebook, which is what we're going to. That's the first feature we're going to pull up. So there's several features of Kubeflow. That is one of the feature. And then what we will do, and this all depends if you have time or not, because I've learned from my exercise since yesterday. So we'll see if we can pull up and create a training exercise, and we'll do that pure Kubernetes fashion. Nothing specific to Kubeflow will get used there, but we'll use kubectl and create a model that is based on a fashion MNIST database, and then we'll go ahead and create an inference endpoint, which is a way to say, hey, hello world, I've got my model here. Go and start asking prediction questions to me, right? So we'll see that firsthand. So this is just a way for you to, getting started. What do I do with if I'm brand new with machine learning and Kubernetes, right? So you get to know those things. Those are the basics. And tomorrow and later we're going to start looking at. We'll start look at fairing, which is one of the feature of Kubeflow pipelines, which is the most popular feature. So for the most part, majority of our customers use Kubeflow pipeline, even though they might be using some of the features of Kubeflow or not. But Kubeflow pipeline is the most prominent feature that's available. So we'll look at that, and then we'll end our session on machine learning.
Awesome.
And yesterday you probably mentioned this, and I completely just went over my head, so I apologize. But we did deploy the dashboard yesterday, and that was really cool because just seeing that dashboard was like this is a full-fledged application for managing your machine learning workflows. So I thought that was really cool to see that dashboard in real time and deploy it. So are we going to get a chance to play with that today too?
Yeah. So I'll the first thing I'll do. So you guys can see the screen, I'm guessing.
Yes.
Yeah.
And if you just hide, there's a little hide button there. It just says sharing, and it's just me being picky. Thank you.
And let's see if my Cloud9 is super small. So let me make it bigger. I'm making it smaller.
And Richard Boyd gets me. I do look best at lower resolutions. That's going to be my tagline, by the way, I think.
So is this better in terms of resolution?
It looks good to me. If I can see it, I bet everyone can see it.
Okay, let me just make it a little bit small because
I was going to say, can you do anything though there?
Yeah. So
one thing that can help is if you click that environment on the left, you'll collapse the file browser, and you'll get a little bit more real estate that way.
Yeah.
Okay, so let me see. Saying click on this one.
Yep.
Okay, cool. Yeah, it does make it much better. Thanks for that, Brent.
Yeah.
All right, so
Richard Boyd agrees with me.
The question is, who said it first?
I don't actually know. I didn't.
I'm going to give this one to Brent. I think I saw Brent say it first. So.
And thanks to Richard Boyd as well. I didn't notice who said it first, but yeah, thanks to you both. So the first thing we're going to do is, so we went through the installation chapter yesterday, right? And as we were talking about it, and for the newcomers, if you want to follow, just go to EKSWorkshop.com and then go to the advanced section, and there is all the machine learning tutorials that we're going to go through. There's installation, how to pull up a Kubeflow dashboard, and all the things that we'll see in the next few days. So let's pull up the dashboard. So that's the first thing that you would do after you do the installation. And the way to run the dashboard is you just use kubectl port forward. And this will let me go and pull up my Cloud9 browser to access my Kubeflow dashboard. All right, so this is the dashboard that we saw yesterday, right? And this is where we stopped. So what we will do is we'll go open another tab because you want to keep that process running. You can actually close this one. You don't need that because we have a tab open with another window. So now let's, and I think we already did this step where we created a namespace. Remember, we gave EKSWorkshop, which actually goes and creates a Kubernetes namespace. So we did this part as well, and then we clicked finish, and we can actually go to the next chapter, which is what we're going to focus on Jupyter Notebooks. So here, feel free to review the information here. Jupyter Notebook is, we spoke about this earlier. Jupyter Notebook is a way to author or write your machine learning algorithms, right? So typically, if you're a developer, you would start from a notebook, go and write your machine learning algorithm. You would write, where your data sets are, how do you pull that in, and then go and run it in order to train a model or create an inference endpoint. So you can essentially do everything from Jupyter Notebook, and we'll actually go and see that in this chapter here. So what we'll do is we'll go to the namespace that we created yesterday, and we'll actually create, the first thing you need to do is you need to create a notebook server, right? A notebook server is where you can go and create multiple Jupyter notebooks. So that's the first thing we'll do, and actually let's go ahead and do that so that you can see that firsthand. So click on notebook servers. So you see there's nothing there right now. So you need to create a new notebook server. And for this one, we will just give it a name, say My Jupyter. And in terms of namespace, actually, you do have to go and select EKSWorkshop, which will populate that field, because that's the namespace that we created yesterday, right? And here you have an option to select whether you want to build the notebook server using a custom image, custom Docker image, or you can pull from one of these listed options, right? So if you use the installation that we provided yesterday, which was with KF AWS plugin, this experience is optimized for AWS environment, and we populate these choices. These are stock images. These are stock TensorFlow images. So for this one, I'm just going to pick the latest TensorFlow 1.15, but there is 2.1 if you want to use that. And in terms of custom image, so the difference is why would you use a stock image versus custom image? Is if you want to maintain full control of the Docker image, right? Let's say you want to maintain and optimize and load all the libraries like TensorFlow, certain version that works really well for your machine learning workloads, or XGBoost, certain version. You can do all of that, build a Docker image, and and make it available. Or you can go and select that over here, upload to ECR, put that ECR URL here, and then you can access it that way.
Now, I think I've talked to some data scientists who end up like combining maybe an image like this with their data, so they'll often like use this as a starting point, then they'll cram all their data into their Docker image, so that when it comes up, all their data is available as well.
Yeah.
Not sure I like that design necessarily, but it does at least lend itself to simplicity. Sounds easy to do.
Yeah, if you have a smaller data set, if it is being used quite often, that might be one simple way of taking additional automation step. I would make use of EFS. If you have a common set of data sets that will get used by multiple machine learning developers, and it's super easy to specify, you just go here and specify the persistent volume that gets created from EFS, right? So you can use an existing one. You can specify the storage class. So all of that is available here. You can
Peter,
change the mode as well.
There is a question I posted up here from KenGet15. Are we trying to create a Jupyter notebook from a Docker image, which has all the ML tools built in? Is kind of how I'm interpreting that. So this, if you want to just maybe elaborate a little more on what this image has and kind of what's built into it.
Yeah, so this is a stock. We're pulling it from GCR, right? So we just made it available as a way to choose. So this is a stock TensorFlow 1.15 version that is optimized to run on CPU. If you have GPU, you can certainly select the GPU version there. If you want to go with 2.1, so this is different TensorFlow versions, right? So we haven't done anything in specific to these images.
Yeah, so these aren't our images. We just put them in this picker box for you so that to make it easy for you to pull them down. That's what you're saying, right?
Yeah.
Yeah, and then a step further, if you did need to customize, that's where the custom image option comes into play. So if you build off of one of these images because you have custom plugins or other features you want in your notebook, you could absolutely do that too.
Yeah. Which we will do when we go through fairing chapter, because
awesome, we'll get to see that then.
Yeah, we'll get to see that. So fairing chapter, pipeline chapter, they're all dependent on using our custom version of image.
Yeah.
So we can see that at that time.
And Green Knight 15 pointed out that we ran into our Docker images becoming multiple gigabytes in size when trying to add their data in, like I was talking about earlier. Yeah. And that was actually my response when I was talking to that data scientist is, that's only scalable out to a certain point. And while it's simple, it's going to potentially cause some issues like that. Also, Docker pull time is going to be pretty substantial. And then if you have any like egress charges or something like that, pulling a 10 gig image, repeatedly is going to cause you problems there as well.
Yep.
Definitely.
Yeah, so I would think of offloading your data, keeping it separate from your Docker image. That's usually the best practice. As you build a thin Docker image, keep it to smaller in size. And use storages such as S3, which is very common in the space. Use S3. You keep all the data there, and then download as you train your model. Or you can use EFS as well. Whichever is cheaper and faster, you can evaluate and go with that option. Yeah. All right, so we're gonna go give one CPU, which is what we highlight in the workshop. Again, no particular reason here. We just want to give it one CPU, one core, and 1 gig of RAM. Everything else is default. We'll just go and click on launch, and it will start creating the Docker image.
And so, Peter, what if I want to make this a reproducible process? I like GUIs. I like working in the UI, but what if I want to build more of an automated process around delivering or dispensing Jupyter notebooks to my team? Yeah. Is that possible?
I'll have to look and see if there's an automated way to create these Jupyter notebooks. But there is an SDK for pipeline, which is what we talked about. It's the most prominent feature in Kubeflow. So one way to use pipeline is through the GUI, and we'll go through that. You can go to pipeline, upload your workflow, and it can run. The other way is to call pipeline from the notebook server, right, from the notebook. And we'll make use of the KFP SDK at that time. And it's a typical practice where you hand over that KFP client SDK to your developer in order to take advantage of that automation so that it's repeatable and they can use it at strength from their side.
Nice.
Yeah, for this one, I think, I've heard customers go with creating a notebook server on EFS volume. So we just use currently, when we built this, we just use the GPU storage class, which comes default with EKS, right? So our
EBS storage class. You mean.
Sorry, EBS, yeah.
Yeah.
But you can put those on EFS volumes. So you can use EFS as a way to share your notebook servers as well as notebooks, right? And I'll tell you the difference. So the notebook server is this, which is what we created, and it's actually a stateful set. So if you go and do...
It's about to ask you to do this.
Yeah. Yeah, if we do stateful set, am I saying it correctly? Oh, there it is.
Oh, yeah.
Yeah, so created a stateful set, which is my Jupyter, right? And you can also see there's a pod that gets launched because of this, which is my Jupyter 0. So and if you go here, connect, which is, it's going to give you an interface where you can start creating notebooks, right? So you can say, create notebook, and I'm going to choose Python 3 as an interpreter. And here you can start entering commands, and these are basically Python commands. So if you do ls, you can also run Unix commands here as well.
So it's probably worth pointing out, we did point this out yesterday, but we're doing all of this using Cloud9, and we're running kubectl proxy to be able to get to this interface. So this Jupyter Notebook server is not currently exposed to the public or anything like that. So just, it's okay. Be aware. That's totally fine. Just want to make sure that we aren't, setting expectations that this is something that you'd be able to get to from the outside.
Yes. Yeah, it's very important. And actually, we did run into a snag before we had the Jupyter Notebook environment or the Kubeflow environment. This Kubeflow interface, we did have it enabled using a load balancer, and we quickly learned that is not the right way to do it, because guess what? If you have a Kubeflow interface that is funded by a load balancer, anybody can get to it, right?
Right.
And we started seeing some crawlers, started seeing some Bitcoin mining, all sorts of things. So you want to be cautious there. Don't put your Kubeflow in front of a load balancer. There is no authentication built into this mechanism. At least the workshop method that we use, right? We're trying to keep it very simple. But if you want to create like a secure way, put Cognito, which is what we recommend as well.
Yeah, and I would imagine that multi-tenant path that exists in Kubeflow probably then includes authentication.
Yes. Yeah.
Yeah. Stitchy E has a question. How is a pod different from a stateful set? They relate. They aren't. Yes, they're different also, but they do work together. A stateful set is just a pod that is stateful, and therefore needs state to be assigned to it for it to come up and go healthy. So typically the pod will make a persistent volume claim, and then that'll get fulfilled by whatever the volume manager in your cluster happens to be. In our case, that's EBS. So it reaches out, provisions an EBS volume, attaches it to wherever the pod is assigned to run, and then maps that resource into the pod so that the pod can see that available space.
Yep.
And there was a question. Yes, we are running this in Cloud9. This is all being run in Cloud9 right now. So the Kubeflow dashboard, Jupyter Notebook. Well, it's being exposed through Cloud9.
Yes.
Right.
Awesome.
That's the better way of putting it.
Let me see if this runs. I'm just trying to see if I can log. Yeah, I can do logging. So, if you want to go and see, if you're an admin, if you want to, want to see what other data scientists have been doing and access their notebooks, this is, you can certainly go and, log, because, this runs as a pod essentially, and you can see that, it gives you all of the logging saying that, you just created a notebook saying Untitled, which is what we have here.
Nice.
Yep. So let's see what else is in this chapter. So we just created a notebook, created using Python 3. So what we can do here is let's get an experience on running a training job, right? So we give you a copy of training code. So you just I'm just going to open it as a separate file here, actually. It's coming up on my Sublime. So what I'll do is I'll copy that. copy, paste it in the first code block, and then click run. And so let me go ahead and copy that over here in my notebook. So this is a sample code. I'll just talk at a high level. I'm not going to go too deep because I'm not a machine learning engineer. Don't ask me questions about what these algorithms are going to do. But I can talk to you. If you look at it, it's easy to understand, right? So we're importing a few libraries like NumPy, which is, it makes number interpretation simpler. Importing operating system, some processes, some arguments, parsing. And then we make use of Keras, which is an API that is built on top of, that is made available on top of TensorFlow, making use of Keras in order to download Fashion MNIST database. So Fashion MNIST database, if you just go in Google, it will show you these are around 60,000, I believe. 60 or 70,000 images, like pictures in really small font, in a small size, right?
Mm-hmm.
So we'll go and download those, and then we run train. We go in and run train reshape, certain. We'll go and do certain things on top of it, and then we go and run the training model, which is again another Keras callback. So we do a bunch of stuff. After this, we go and export. We take the model that is created. We go and export that. We go and save that, and that's it, right? So, and we have a main program which walks you through those things step by step, which is train in images, model, evaluate, and that's it, right? So that is what this program
probably
does.
then trying to classify images.
Exactly.
Yeah.
And I think the normal like super basic level is if you are trying to like identify train a model that can identify a dog, then you would probably pass it a ton of images of dogs and let it start to recognize that, hey, this is what a dog looks like, and it can know that these images are all dogs, and then later when you run it for real, you can hand it an image and it'll figure out
What type of dog it is.
Yeah, what's the percentage likelihood that the image I'm looking at is a dog.
Yeah, and if you have within your algorithm, if you've categorized them saying this is a bulldog versus Pomerian, or different types of dogs, then it can also say with prediction that the model thinks or the AI thinks that is a particular type of dog.
Yeah. Cool.
Yeah.
And usually that's represented in like a confidence score, right?
Yep. Got it. All right, so that's what we'll do. So we copy this training code. We paste it on a Jupyter notebook, and we will go and copy this main, or just say run main, which is the code that we have here. And the way to run these are you just select that and click run, or you can say shift enter. At least on my Mac, I think Windows also has similar concept. So I'm just going to say run.
Nice. And the data set, there was just a question around the data set, but it looks like this was a fashion. What was the data set we're calling again?
Fashion MNIST database.
The Fashion MNIST database. Thank you.
Yeah, you'll see that it's pulling those database which are available. It's a publicly available database. And these epochs that you see that is running here, so those are several layers. So whenever you create a training job, you want to say how many times you want the machine to go and run the algorithm in order to get the best possible outcome. And this was the output that we were expecting, right? So we were expecting to see here's the data set that is available. It's Fashion MNIST data set. Here's the algorithm. go and run it against this algorithm and go and evaluate using a sample data set, which is, we give it the 10,000 sample data set. It's all in the algorithm. And once you do the comparison, come up with the test accuracy, right? And the machine learning model that was generated, it's spitting out a score saying that it's 87.5% accurate, which is good for our observation for this exercise. Yeah, and there's some verbiage here on what we just did and what you are expected to see.
Cool.
Nice. Yeah. So that's about it about the notebook experience. And we can go to the next two chapters, which is we're going to create a trained model. We go and pull again. We'll use the same fashion MNIST database. We'll train a model, and then we will create an inference endpoint.
Will we train a fashion model?
Oh, you mean like fashion model? No, I don't know. No, not for this one.
Yeah,
Total
I see what
joke.
you did there.
Yeah,
see what you did there.
Thank you. Let's do it. Let's see it. Let's get going.
Go to the next one. Yeah.
So Richard Boyd liked that joke, by the way.
Thanks, Richard.
So this is So we'll pull a fashion MNIST database, and then we'll follow the similar exercise, but in this time when we run it, we'll use a custom image, which has been optimized with TensorFlow, a certain version of TensorFlow, and we also have some libraries that are pre-built in this Docker container. So we'll go ahead and use that. So let's go with this exercise. I'm going to close this notebook because we don't need it anymore.
So the notebook is just sort of a semi-ephemeral IDE for running training and expressing your algorithm, right?
Yeah.
You could reopen it right now, but it's not something that needs to constantly be running or anything like that.
Yeah. So you can see the difference there. It's showing green because I just had it open. So if I open it, it will show the previous state, right? Which is I ran these. So if it has a number there, that means the third time I ran this particular cell, and then fourth one I ran this cell, and you can see what we exactly did, right? Give the test accuracies. If you want to leave it like this, you can leave that. For us, you can also go and click shut down, which is, it just goes and kills that notebook process that has been running on a notebook server.
Gotcha.
But yeah, if I would say one best practice is this is your footprint. If you want to capture this as infrastructure as code, and if you want to have like a reusable pattern of, hey, I just wrote an algorithm. What did I do 2 days back? Can I pull that state? Go ahead and capture this, right? It's JSONified text, I would say. I don't know what, but you can easily understand, what whatever information that you put in these notebooks.
And yeah, thanks for the shout out, Mahesh B. Adam, which I like to believe that my influence is so great that Mahesh has officially added my name to his name. So I really appreciate that, and I'm honored. Thank you.
There is no greater honor.
That might be his last name.
It could be,
might
but
be.
I just want to believe what I want to believe. Okay, Peter, don't take that from me. Thank you.
All right.
Anyways, I'm kidding.
Okay.
Moving on.
Yeah, let's go do these two next chapter because they do fall together, training and inference. So here we're going to use a pre-built Docker image, like I said. So I'm going to copy this. And if you want to build your own image, or if you want, if this is the content of the Docker image. It's very basic, 3 lines of code. So we'll use that Docker image as the base image. So let me go ahead and do that.
I'm sorry. Thank you, Richard.
Again, we tend to laugh. I remember one time, I was doing we were doing the show and Brent's laughing, and I'm like, why is Brent laughing at me? What did I do wrong? And it's not. We just have a lot of funny people, funny content in the chat. So just know, Peter, Brent's not laughing at you or me. He's just laughing at the chat, or with the chat, I should say.
Yeah, I'm good. I was just reading if I'm doing things correctly here. That's all. That's what I was taking my time.
Perfect. Hey, Dave. Hey, all our friends are here.
I know, right? I'm
So
always laughing at Richard Boyd.
I'm laughing with Richard Boyd. Okay,
Fair enough.
This is the difference. See, now Richard, I expect the last name to change to incorporate me. So.
Okay.
Wow.
Whoa, Nick the Lurker stopped lurking. Welcome, Nick.
So,
hey,
so
Dave.
where are we at, Peter? What's going on?
Yeah. Let me go and run these set of configurations that we're highlighting here. So first thing we're going to do is we'll create an S3 bucket, which is there's commands that we need to run in order to create an S3 bucket, and we've got it automated, and we'll see what we mean by that. So these commands you do have to run it in Cloud9.
Mm-hmm.
So let's go ahead and do that here.
So we're creating a bucket, and this bucket is where we're going to store our training data. Is that right?
The model that we created.
We're storing the model there. Okay.
Okay.
Cool.
The output is going to go in this bucket. So we can actually go there. We'll go to S3 here.
The console is so zoomed in and enormous.
Oh, it is? Okay. Let me just
beautiful.
No, it's good. It's good.
Yeah, it's beautiful.
That's good. Okay.
It's perfect.
So that is the bucket that we just created, right? Right now, there shouldn't be anything in there. Okay. So that's what we did. Let's go here. Oh, not actually. Let's go here.
While you're doing this, there's just a question. What we're doing today. So I'm just going to do a quick, recap of what we're doing. Yeah. Kind of level set. Use that term. Okay. Anyways, so we are. So the past since yesterday through today and going on, we're basically deploying Kubeflow onto EKS, and we walked through deploying a Jupyter notebook, and now we're actually we took a data set, we ran basically ran some training against that data set, and now Peter is walking us through actually training a model, and hopefully we'll be able to deploy a model as well. So machine learning on EKS.
Using Kubeflow.
Yep.
Thanks, Brent.
Anytime.
Yeah, and the one step that we did here with this training chapter is we created the S3 bucket. And what I'm going to do is I'm going to create a notebook server using this image that I spoke about earlier. And I'm going to name it. So this is going to go into custom image right there. And we'll just name it my Jupyter 2.
So we have one notebook server. Why would we be making a new one? To get the different image?
So this image actually has the algorithm built into this notebook image. So, if you want to automate certain steps, right, and you can actually see, you can see what the Docker file is here. So it has 3 lines of code. The image is going to pull TensorFlow, certain version of TensorFlow, and then we're going to copy the Python code, which is on this repository, and then we're going to run this code, right? So if you want to automate your development process to certain level, this is one way to do it.
Awesome. Green Knight, while you're going, keep going. Green Knight 15 asks, what would be the use case for Kubeflow over something like Sagemaker? And we did kind of touch on that yesterday, but to recap, basically, Sagemaker, well, one, it's not either or. Kubeflow can actually work with Sagemaker. And two, Sagemaker gives you a managed experience where you don't really have to worry about running or updating or maintaining your infrastructure, and Kubeflow would be probably a far more customizable experience where you can, have greater control over all of the different aspects of the environment, and then potentially the two can work together in the end. And do we see that, Peter, later in the workshop, or is that something that we should think about adding to the workshop?
See what? What was that again?
Using Kubeflow with SageMaker?
Kubeflow with SageMaker, yes. Yeah, we will see that in Kubeflow pipeline chapter.
Perfect.
Yeah, we're going to use Kubeflow pipeline and run our training jobs on SageMaker and I believe Inference endpoint as well. But yeah, we will be running both pipeline and SageMaker together.
Cool. Okay, so we've created our S3 bucket for storing our model.
Yep. So we've done that. Now let's go and we'll create a secret, which is, so if we run these next 3 blocks, we'll go ahead and create a secret in order to access S3. So imagine what we're trying to do is we're running a Docker container, Docker image, when we go ahead and run the MNIST model, which is right here, right? MNIST training model. And what that will do is it needs to interact with S3, right? In order to interact with S3, there is different options that are available. The best way to make it available is using URSA, IAM role for service account that we spoke about yesterday. With this one, we're taking an easier approach, right? With this one, we're just creating a secret which has the S3 credentials, the API keys, which we will generate now. And I'll go through the steps and store it as an editable secret. The reason we do that is because not all libraries that you're going to use in your machine learning workflow is going to have an integration or the AWS SDK that is required to enable IAM role for service account. So if your algorithm works, if all the libraries that you use, those are the dependencies, if they have the right AWS SDK, then certainly make use of IAM role for service account. But keep in mind it may not work the way you think it might. So basically,
the way some models have been built, or some of these training models, they may use like the provider chain where they can look at your environment variables or other aspects to deploy or to talk against the AWS APIs, but some may not, and they're a little more old school in nature, where you need the actual credentials.
Yeah, they have the older SDK version. I don't remember exactly what's the version that you need to use, but if you look at the announcement of IAM role for service account, it specifies the required AWS SDK version.
Makes sense. Cool. So we're going to get this going.
Yeah.
And I know I got to tell you, time really does fly when we're doing these shows.
All right. So let me crank this up. So I'll go and run the 3 commands, and I'll talk what we're doing here. So we need those API keys, right? In order to API keys, we need to create a user. So we create a user called S3 user. We attach a policy. We give it S3 full access. We say, here's the user, give him S3 permissions. And then we create the access key. And now we're going to go and grab those API keys. We'll store them as environment variables. So if you go and do echo access key ID value, it's going to spit the output there, but if you do base64 code, so that's the API key, right? And the same thing with secret access key is going to be stored in here.
Don't.
I'm not going to do that. Yeah.
Okay, good.
Yeah. So so we're going to go and store this over here by creating a Kubernetes secret, right? So we just created the way to access our S3. Now let's go ahead and create that training job that I was talking about, right? So that is stored in this MNIST YAML. We'll actually go ahead and download, and we'll take a look at that code. I did speak a thing wrong earlier, and I will quickly correct that because now I recall what mistake I did. Okay. So we ran the next command, right? Which is going to spin up a training job for us. So let's actually go and see if it's doing it. Yeah, so you see that there's a training job that is getting created, and it's going to go ahead and run. Let's go and open up the training job. So this is the YAML, the pod template that we just ran, right?
Mm-hmm.
So the thing that I misspoke about was the Docker container image that we were looking at earlier. That was not for the Jupyter notebook. So I got confused earlier. So that's why I was spending time, am I doing the right thing or not? But that container image is actually what you would use in your training job, right? Yeah, so keep that in mind. That was the mistake that I did there. So if you see here, this is the it's a classic pod that we're going to run. We specify where the image is, and this is, we saw what the contents of this image is earlier, right? And here we say, when this container starts, run Python mnist, which is already baked into this container, and we say here's where you want to store the model, right? Which, we gave it S3 bucket. Remember, we created an S3 bucket, and we, so these both are our model particulars that we're going to create. We also specify epochs, right? So we say 40 epochs here. So that is what we did here. So I'm actually going to go and delete this because this is not going to work.
Nice. So a quick rebuild there.
Yeah.
So easy.
So if we do get pod, you can see it's running. Now we can actually go and do logs. If you see, we're not doing anything that is Kubeflow optimized. We're not using any Kubeflow features here, right? We're just using plain old Kubernetes for doing this stuff.
You're not even running this in the namespace that you created. This is like
default
namespace.
Default. Yep.
Yeah.
Yeah. So it's it's still running. It's ran 20 of those 40 iterations that we've told. So once that is done, let's go and review what's going to happen next. We say, that's how you check it. It's running. You can also see, you can expand these and see what options you have there. The next one is going to be, we're going to run inference. So here, so inference is essentially, remember what I said, once you have a model, you create an inference endpoint, right? So our model that gets generated, it's going to go and stay in S3. We need a way to host that model. So in order to do that, we're going to run this mnist inference. It's going to pull that model.
So quick recap, we trained the model on the fashion data set. We're storing that model in S3, and now we're going to create an inference endpoint using the model that we built and trained.
Yeah. Yep.
Perfect.
Yeah, and so this is going to let us run the inference endpoint. And once you have an inference endpoint, we're going to use port forward. So I don't want to jump too much ahead. So let's just go one step back.
Yeah, because we only have like 5 more minutes.
Yeah. We'll see if if you're going to be able to do this, but if not, we'll come back tomorrow.
Yeah.
Yeah.
Cool.
It's always a surprise. Okay, so let me go back here. Let me just check if it's completed. It's still running.
Hey, that's what it takes to train the model, folks.
That's right.
This is big picture stuff here. This is big picture stuff.
It's actually tiny picture stuff.
That's to create one big. No, I don't know.
It's 10,000 tiny pictures. One big endpoint. 10,000 tiny pictures.
Okay.
Yeah, so you can see that the folders are created. These were not available earlier, right? Let's see the model. Let me see if it's there. Yeah, so this is the model, saved underscore model that you'll see here.
Nice.
Which is about 115 KB. I guess it's done finishing, but so once it's
side note, I think it's fascinating that the training and everything takes huge data and lots of processing, but then once the model is built, it can be super tiny and it can be shipped around and run on like your mobile device, and a lot of times it doesn't take a lot of processing power to be able to run these pre-trained models. So that's really cool.
Yep. All right, so our training job is complete. Now what we can do is we can do those inference steps in order to expose those endpoints. So we'll go and run this command, and we'll look at the code as well. So here we downloaded MNIST Inference. If you see, it's exposing as a service, right? MNIST Inference as a service. It has, it listens on certain ports. So it listens on HTTP and gRPC. So that's just the way to communicate with this model inference that we're going to create. There's also deployment, and within deployment, we'll say here is where the model is. We give it the path to the model. And then we'll say expose it on these ports so that I can talk to these, right? So let's go and actually run kubectl get pods. You can see that the inference endpoint is running, right? Which is a good thing. Now we're going to do port forward. We'll expose the endpoint that we just created using another port, which is 8500. Okay, so now we have we have our model that we just created. We have an endpoint, and it's listening on 8500. So if I do a curl back and say 8500, I can talk to that endpoint, right? Which is I can start making predictions. So in order to make predictions, we do have to load certain things on our Docker on our Cloud9 environment. Remember, Cloud9 is
done in 2.5 minutes because I am dying to see this.
Let's take a look.
I know the audience.
This thing does take some time, but we'll see if we can complete it.
Python.
It's TensorFlow. It's a beast. But we'll see if we can complete it.
Cool.
I wonder if we have anyone going after us.
Brent, this is the reason. This thing fails if you use a smaller Cloud9 environment. This was the reason why we went with the next step.
Is it the CPU or the disk space?
It's CPU.
Okay.
Yeah.
Yeah, I think disk space is just 8 gigs across the board. But hey, Richard, I know we're working on that, right?
Exactly.
Actually, I don't know
disk space.
We'll edit what I just said out. Maybe I don't know. I don't know if it's public knowledge. Yes, you can resize it, and I have some code to do that. And it's in the docs, so it's perfect.
All right, so once we have all of those things loaded in our Cloud9, we should, once we go, we can go ahead and hit our 8500 localhost and run prediction, and we should be able to see this
Sweet.
little burb.
Let's do it.
It's still building.
Oh,
Yeah, this is the part. It
you
takes a
said
couple minutes.
once, and I just assumed that meant now.
No,
but-
we have to wait until this finishes, unfortunately.
Fair enough.
We can take questions. I think we have like a minute or so until this gets installed.
So Richard suggests that if we did this with Lambda, one rule you could build into the algorithm is if you can't infer in 15 minutes, just return true. So everything is a whatever. That would be pretty incredible.
Yeah.
It's good. Let's return true.
Cloud9 doesn't like ports that are earned 8,000. Yeah, Cloud9 is very peculiar about the way it works with certain ports, and I think the only, if I'm not wrong, correct me there, Brent or Adam.
Yeah,
I think it only exposes like 3 ports.
Is it 3? I think that must be up from 1. 8080 I thought was the only true port with Cloud9.
Yeah.
So yeah, if it's more, that's pretty incredible.
Yeah, it limits our things that we can do in Cloud9 for sure.
I love it. Is it a hot dog? Probably.
Yeah. So listen, it looks like we're probably not going to get to test this inference today, but that's okay. The good news is it'll be installed by tomorrow, all these packages, and we'll be able to test it most likely tomorrow. I think this is probably a good point to stop.
Yes.
Richard, stop holding your breath, and tomorrow we'll be able to continue on. So just a quick recap, and then let's end it for today, and then we'll see everybody tomorrow. But today we got a Jupyter Notebook deployed, ran some tests in our Jupyter Notebook, built a model. We didn't get a chance to actually test inference on that model endpoint yet today, but we will tomorrow. And then what else should we look forward to tomorrow, Peter?
So tomorrow, that's the first thing we'll do. I'll come over here and probably run the install packages just to show that we need to run this. It's going to come up with it's already installed, but
yeah.
We'll do that. We'll see the things that are running. So there should be a training job that is completed and an inference endpoint that is created. We'll take a look at that, and then we will go and run predictions. So this is going to be quick. And after you run predictions, we should expect to see a blurb like this, which will say the sample data set, which is 10,000 images. It's one of those images will send it to the model, and it will say the AI model thinks that this picture is this, and it was actually this, right? So expect to see something like this when we do the prediction.
Perfect. All right. Thank you, everybody. We will see you tomorrow.